my dear PU1 students. So yes, we know that your exams are going on. So to help you with your preparation, I have come up with a one short video where I'll be telling you all the important formulas, all the important terms and concepts from each and every chapter that you must be focusing, and I'll also be telling you all the reactions that you have to study. Okay, so these will be the most important topics from all the chapters. So at least you have to do these many topics and go for the exam. Okay, so this is like a checklist. You have to put this, you have to take a screenshot or note it down. For example, structure of atom, I have given you the topics, so you have to just put a check mark whether you have studied this or not, whether you have known, whether you have remembered these formulas or not, whether you have done this question or not. So this type of a checklist video will be there, which will help you to verify that you have completed all the important topics, all the important formulas, all the important name reactions from all the chapters. Okay, let's get started, students, and I want all of you to sit with a notebook and a pen and note down all the important points that I'm going to tell in this video. Okay, so the coming to lecture number, the first chapter, that is some basic concepts of chemistry. So what all things you have to focus on this one. The first one is your laws of chemical combination. Okay, all the 5 laws you have. What all laws of conservation of mass, multiple proportion, definite proportion, law of Avogadro's law and Gay-Lussac's law. Its statement you must remember directly from the NCERT book. Next you have the definition of limiting reagent. What is a limiting reagent? These questions have been asked many times, so make sure that you have done this one. Then questions from empirical formula and molecular formula. How do we find that? This is very expected question. Make sure that you have done similar type of questions. Then stoichiometry questions, this I will explain in the next slide. How to find significant figures, mole concept, how to convert from moles to atoms, atoms to mass, mass to moles. These all conversions you should be knowing, so I'll be telling you that here. So if you have moles, okay, and you want to calculate number of particles, okay, if you have moles and you want to calculate number of particles, then what you have to do? You have to multiply with Avogadro number, and if you have number of particles and you want to calculate number of moles, then divide by Avogadro number. Now similarly coming to mass, okay, so if you have moles and you want to calculate mass, then multiply with molecular mass, and if you have mass and you want to calculate moles, then divide by molecular mass. Okay, next thing we have is our volume. Okay, so if you have moles and you want to calculate volume, then you have to multiply by 22.4 liters, and if you have volume and you want to calculate moles, then divide by 22.4 liter. Okay, so this is done. Then the next one is your how to find the average atomic masses if the abundance is given. So that is your percentage into molar mass plus percentage into molar mass divided by 100. Okay, so these all things are done. After that, I'll tell you the stoichiometry questions that I told you. See, stoichiometry questions will be of 2 types. One question will be where the reactant is given and the product question is asked, or how much amount of product will be formed. So for example, you can say calculate the amount of water produced by the combustion of 16 gram of methane. So if you see 16 gram of methane, I have CH4 plus O2 gives CO2 plus H2O. Okay, so you have to balance the reaction. Here we have been given with 16 gram of methane and we are asked with carbon dioxide term, right? Now see, there are 2 reactants here. So whenever only one reactant is given, okay, then directly you can use the stoichiometric relation. Like for example, if I see the balanced reaction is like this, so I can say 1 mole is giving me 1 mole of carbon dioxide, on 1 mole is 16 gram, so 44 gram of carbon dioxide will be produced, right? And the question is asking to calculate, so amount of water also. So like this is 44 gram. Now 1 mole is giving me 2 moles, right? So 16 gram, that is 1 mole, will give you 2 moles, so 2 moles means 36 gram of water will be produced. These type of questions will be very easy and can be asked in your 2 mark section. Now coming to the other type of problem where you have both the reactions, okay, like for example, if you have this reaction, that is, yes, suppose you have this reaction, right, N2 plus 3H2 gives 2NH3. Now in this reaction you have been, suppose if you see 50 kg N2 is there, okay, and 10 kg H2 is there. Okay, now it is mixed to produce a certain amount of NH3. right? So now when this type of question arises, when you have the quantity of both the reactants, in that case you first need to find the limiting reagent, and once the limiting reagent is obtained, based on the limiting reagent you have to find how much product will be formed. Okay, so that is two type of stoichiometry questions that you can expect from this chapter, and you should practice both this type of examples. 2 to 3 questions you can practice from both of them. Now let's move to the next chapter, that is structure of atom. Here a lot of concepts are there. Okay, so please, Dalton's postulates, very important question. Please remember at least 3-4 postulates. Rutherford experiment and conclusion, or Rutherford model of atom. Bohr's postulates, again very important. This can be a 3-marker, 5-marker questions. Hydrogen spectra, only you have to learn the formula. Okay, that we will discuss. Next, quantum number and significance, very important question. Repeatedly this question have been asked for all the 4 quantum numbers. You should know what symbol it denotes, what is its significance, what information does it give, what is the range of this quantum number. All these things should be given here. Next, electronic configuration, how to write, you should know, especially these 2 elements, that is chromium and copper. So let me just revise. Chromium electronic configuration is argon 4s2, sorry 4s1. Okay, 1 second. Okay, so for I'm getting some trouble here, pen, yeah. So now for chromium it is argon. Okay, then you have 3d5 and 4s1. For copper it is argon, okay, 3d10 and 4s1. Okay, next coming to the term, that is your radius and energy of an electron. So here also you should just remember the formula. Okay, and hydrogen spectrum, as I told you, is also you have to remember the formula. We will discuss the formula in the next slide. Next, photoelectric effect, you should know its definition, diagram, okay, plus formula. Okay, so just put if you have learned all this, put a checklist, otherwise go and revise this topic. Next, Heisenberg uncertainty principle, both statement and formula and numerical. Okay, de Broglie wavelength, same statement, formula and numerical. Next, principles of filling electrons. Here we have 3 principles that you should be knowing, that is your Aufbau principle, Hund's principle and Pauli's principle, right? Their statement you should be learning. Okay, their statement you should remember. Next, what is the difference between orbit and orbital? This can also be a very potential question. Just practice 3 to 4 points. Okay, now let's dive in to see the formulas that we have discussed. So first one is your characteristic of wave. Here we have this formula, C is equal to lambda into mu. Okay, or you can write this one as, yeah, so this is your formula for the first one, okay, where C is the speed of light, lambda is wavelength and mu is frequency. Clear? Okay, next here we have one more formula, E is equal to h nu, and I can write this one as E is equal to hc by lambda. These 2 formula for the wave. Next, coming to Bohr's atomic model. So here we have formula, first is your mvr is equal to nh by 2 pi. Okay, this is there. First formula. Then we have r of any orbital is equal to 52.9 into n square by z picometer. Okay. Next we have energy, En is equal to minus 13.6 z square by n square eV, or minus 2.18 into 10 to the power of minus 18 z square by n square into joules. Okay, so this is happening here. Next, coming to hydrogen spectra. So to calculate hydrogen spectra, you have this formula, 1 by lambda is equal to 109677 into 1 by n1 square minus 1 by n2 square centimeter inverse. We all know this formula. Now here we have Lyman series, right? Balmer series, Paschen series, then we have bracket series, and then we have P-Fund series. Okay, so here N1 and N2 you should be knowing. So these are the values, and here it can be 2, 3, 4 anything. Here it can be 3, 4, 5 anything, 4, 5, 6 anything, 5, 6, 7 anything. Then you have Okay, so these are your hydrogen spectrum revision formulas. Next we have here photoelectric effect. So photoelectric effect formula is your h nu is equal to h nu 0 plus kinetic energy, where this is the energy of the light. Okay, energy of incident light. Okay, h nu 0 is your threshold energy. Okay, and Ke is your kinetic energy. Okay, so this is the formula. Here any term, one term can be given and other terms can be asked in the exam. Next, coming to Heisenberg uncertainty principle, you know the uncertainty in the position and the uncertainty in the momentum is greater than or equal to h by 4 pi, where h is your Planck's constant, its value is 6.63 into 10 to the power of minus 34. Okay. Next, the delta p is the uncertainty in momentum. Okay, now coming to de Broglie wavelength. According to de Broglie wavelength, lambda is equal to h by p, or I can write h by m into v, where h is again Planck's constant, m is your mass, okay, and v is velocity. Right? Okay, so these were the formulas from this chapter. Okay, next we'll move to classification of elements and periodic table. So here first thing is your properties. You should be very clear what happens to the size, what happens to the ionization energy, electron gain enthalpy along the period, down the group. Okay, that is the first thing you should revise. Next, what is modern periodic law, what is Mendeleev periodic law, what is their difference definition. Then the nomenclature of the elements more than 100. Okay, that nomenclature rules you should be knowing. Then isoelectronic species and to arrange the size of these atoms in isoelectronic species. So always remember, first will be the size of anions, then you will have neutral atoms, and then you will have cations. And in properties, the most important properties that you should remember is ionization energy. Okay, from here most of the questions will be asked. So all the exceptions, okay, especially for nitrogen and oxygen, okay, you should be knowing why the ionization energy of nitrogen is more than oxygen, because of nitrogen half filled electronic configuration. Okay, so this is most important thing from this particular chapter. Now moving to the next chapter, that is your chemical bonding and molecular structure. So many important concepts you should remember here. The first one, you should know how to draw the Lewis structure. So whichever examples are given in the NCERT, please practice those Lewis structures. Next, Vesper theory and hybridization. Okay, so in Vesper theory, what you have to remember? You have to remember the geometry, the shape, okay, and the hybridization. Okay, next we have MOT. In MOT, what you should be knowing? How to write the MOT electronic configuration, okay, electronic configuration, then to calculate the bond order and the magnetic properties. Okay, next we have formal charge calculation. Formula we will discuss. Resonating structures, especially for CO3 2- and ozone. These two resonating structures you should prepare. Next, dipole moment of NH3 and NF3. In NH3, the dipole moment is greater than NF3. What is the reason? That you should be knowing. Then conditions for linear combination of atomic orbitals, very important. 3 conditions are there. So one is your, they should have similar symmetry, size, sorry, not size, symmetry, then we have energy. Symmetry, energy, and then we have something which is your extent of overlapping. Okay, next we'll talk about hydrogen bonding, where we have intermolecular and intramolecular hydrogen bonding, and 9th one is the difference between sigma and pi bonds. Okay, so let me, okay, so here I'll tell you the formula for formal charge. So total number of valence electron minus number of non-bonding electrons minus number of non-bonding electrons minus bonding electrons by 2. Okay, clear? Next we have something thermodynamics, very important chapter again. So here first of all you should be knowing the types of processes and types of system. Types of system: open, closed and isolated. Types of processes: isothermal, isobaric, adiabatic, isothermal, right? Sorry, isothermal, isobaric, isochoric and adiabatic. These all formulas, definitions you should be knowing. Next, what is intense property, extensive property and their examples. Okay, so examples are a must. Next, path function and work function, sorry, path function and state function, okay, and their definition and examples you should be knowing. So remember, path function is only to work and heat, all other are state function. Then work done, derivation should be, you should practice. Numericals on work done is a must, so please do maximum numericals on this topic. Then what is specific heat capacity, what is molar heat capacity, their definitions, okay. Then enthalpy change for the reaction, how to calculate. Then conditions for spontaneity, you should know delta G should be negative and delta S should be positive, okay. Next, what is Gibbs free energy and its formula, okay. So we will discuss that. Yes, so work done in isothermal reversible process, the formula is W is equal to minus 2.303 nRT log of V2 by V1, okay. Next we have minus 2.303 nRT log of P1 by P2, okay. Next, work done in vacuum, here work done will be equal to minus P external into delta V, clear. And here if the work done will be equal to 0, clear. Now heat capacity, so heat capacity formula will be equal to how can I write, Q is equal to MC delta T, okay. So this is for specific heat capacity, and for molar heat capacity NC delta T, right. Here it is the specific heat capacity, here it is the mass, here it is the number of moles. Then relation between Cp and Cv is equal to R. Its derivation also you should practice, very easy small derivation. Next, enthalpy, what is the formula? Enthalpy of a reaction is equal to the total enthalpy of products minus the total enthalpy of reactants, okay. Next, Gibbs free energy, delta G is equal to delta H minus T delta S, okay. So here T is temperature, delta S is spontaneity, delta H is enthalpy, delta G is Gibbs free energy, okay. Now we have another formula for delta H as well, that is delta H is equal to delta U plus delta NG RT, okay. So delta H is enthalpy, delta U is internal energy, delta Ng is the number of moles of gaseous products minus reactants, R is your gas constant and T is the temperature, okay. Fine. Next, moving to equilibrium chapter, here you should be knowing something about characteristics of equilibrium. Then Le-Chatelier principle, very very important, all the effects, that is effect of concentration, effect of temperature, right, effect of pressure and effect of, next one we have is inert gas addition, okay. Inert gas addition at constant temperature, at constant pressure, okay. Next, what is homogeneous and heterogeneous equilibrium and their definition, clear, okay. Next we have here is the formula for equilibrium chapter. So suppose I have a reaction like this, AA plus BB gives CC plus DD, then what is the expression for Kc? It is D to the power of D, C to the power of C, then you have A to the power of A and B to the power of B, okay. Next, Kp and Kc relation, Kp is equal to Kc into RT to the power of delta Ng, right? Next, QC and KC, what is the relation? So QC is your, if QC is less than KC, reaction will go in forward direction. If QC is greater than KC, reaction will go in backward direction. If QC is equal to KC, then reaction is already at equilibrium. Next, what we have to think? KC and stoichiometry. Here also 3 points I have. So if a reaction is there, okay, so let me just write down a reaction. Yes, suppose I have a reaction A plus B gives you C and its equilibrium constant is K1. Now suppose I am multiplying N to the whole equation. So what I will get? Na plus Nb gives you Nc, right? Now what is the equilibrium constant for this reaction? Okay, so if you have multiplied N to the whole equation, it will become K1 to the power of N. Okay, now second one, if you have reversed this reaction, that is reverse, means C is giving you A plus B. Okay, so now what will happen if the reaction is reversed? Then what will be the value of K here? 1 by K1. Okay, the equilibrium constant will become 1 by something. Now third one is, suppose I have another reaction, P plus Q is giving me R. Okay, so if I add these two reaction, K1 and K2, then if I add these two reaction, then the K value will be K1 into K2. Okay, so this is how questions can be asked from this particular part. Next, coming to buffer solution, what is the definition of buffer solution? You should be knowing definition, types. Okay, next I'll tell you the formula for acidic buffer. What is the formula of acidic buffer? pH is equal to pKa plus log of salt concentration by log of acid concentration. Okay, next, how can you find pKa value? Is equal to minus log of Ka. Okay, this is for acidic buffer. And if it is a basic buffer, then the formula will be POH is equal to pKb plus log of salt by base, right? And here again, what is pKb? pKb is minus log of Kb, right? I hope all of you have remembered this formula. Now coming to salt hydrolysis, we have 3 types of salt hydrolysis. So first one is, I'll take strong acid plus weak base. Okay, if this is the salt, then pH is equal to 7 plus half pKa plus half of log C. Okay, next I will take strong base plus weak acid. Okay, strong base plus weak acid. So this one, pH is equal to 7 minus half pKb minus half log C. Next, if I have weak acid plus weak base, okay, here the formula pH will be equal to 7 minus half pKb, okay, plus half pKa. Yes, pKa. Okay, so yes, please check the formulas once again. Fine. Now we'll move to the next topic here, that is pH and OH. What is relation? So pH plus POH is equal to 14, right? And here what is the formula? Ka into Kb is equal to Kw. Now for any type of the salt where we have Ax and By, okay, what is the Ksp here? Ksp is S to the power of X, S to the power of Y into, no, sorry, not like this, sorry. Formula here is X to the power of X, Y to the power of Y, S to the power of X plus Y. Okay. Now we have redox reaction. Very simple thing you should be knowing here, how to calculate the oxidation number, how to balance the redox reaction, both the methods, that is your oxidation number method and half reaction method, right? And in that too in acid medium and base medium. Okay. Next, oxidizing and reducing agent, which is an oxidizing agent, which reaction is undergoing oxidation, which reaction is undergoing reduction, those things you should be knowing. Next, coming to organic chemistry, the first chapter, some basic principles and techniques. Nomenclature, all the rules should be there. Isomerism, all the types of isomerism. Inductive effect, hyperconjugation, resonance effect, okay, especially this resonance effect, please learn properly. Then methods of purification, special emphasis on chromatography, distillation and separating funnel. Okay, so chromatography you have to give more importance. Then quantitative analysis, Zeldal method and Carrier's method. Other methods are also there, but yes, these two methods are mostly asked, especially the Carrier's method. Okay, so let us see some formulas here. For if you want to have Liebig method, for that percentage of carbon is 12 by 44 by W1 by W into 100. What is this W1? W1 is mass of CO2 produced. Okay. Similarly, for percentage of hydrogen, 2 by 18 into W1 by W by into 100, where W1 is your mass of water. Okay. This W is what? Mass of organic compound. Okay. Next, in Dumas method, if you want to calculate the percentage of nitrogen, 28 by 22400 by V1 by W into 100. Again, W here is the mass of organic compound. Now coming to the third one, Zeldal method. Here also you have to calculate the percentage of nitrogen. So 1.4 by W. W is again the mass of organic compound. Normality. What is normality here? Normality of H2SO4. Okay, and then volume of H2SO4, that is used to neutralize the amount of base produced. Okay, now we will go to next one, that is Carrier's method. Here percentage of AgCl, so 35.5 by 143.5 into W1 by W into 100, where W1 is the mass of AgCl. Percentage of Br, 80 by 188 into W1 by W into 100, where this W1 is the mass of AgBr. Percentage of I, 127 by 235 into W1 by W into 100. So here it is mass of AgI. Percentage of sulfur, percentage of phosphorus, you can see the methods. Okay, this is the formula. Now we will move to the next chapter, that is hydrocarbon. So here we have again same thing, nomenclature and isomerism we have to practice again. Then we have to remember this reaction, Woods reaction, very very important. Decarboxylation, Cole's method, all the three name reactions are very important. Okay, then solubility and melting point, what is the property? When the mass increases, solubility decreases, mass increases, melting point and boiling point increases. So these all trend you should be knowing. Then electrophilic substitution reaction for haloarenes and their mechanism, so you have to just know the mechanism, then different haloarenes can replace that one. Okay, next we have addition reaction of alkenes, Markovnikov's rule and anti-Markovnikov's rule, Seitzef rule, the definitions you should be knowing. Addition of HBr and peroxide effect, that is the same, Markovnikov's and anti-Markovnikov's rule. Then ozonolysis in alkenes and their products. Okay. Next, yes, so that's all students. So this is a list of all the important topics from the chapters. So make sure that whenever, if you are thinking that a chapter is completed, please give a look to this list and just put a tick, okay, these all things I have done. So if you are doing this much, then also you will be able to get very good marks in your final exams. Okay, all the very best students. If you have any other doubt, please put down in the comment section. I will definitely address to it. Thank you for watching and do not forget to subscribe the channel.